Hi students, today we have to discuss the chapter force on a current carrying conductor in the magnetic field. We have to discuss the topic force on a current carrying conductor in a magnetic field. Take a coil and that coil connected to battery. That means a current carrying coil is placed in the vicinity of magnet. This is horseshoe magnet, that is U magnet. Okay, so a current carrying conductor is placed in a magnetic field. It will experience a force, that is force on a current carrying conductor in a magnetic field. Okay, the French scientist Henri Marie Ampere suggested that the magnet exerts a force on the current carrying conductor placed in the vicinity of a magnet. So it is a coil having current. So it will experience a force because of the presence of the magnetic field. That is suggested by Henri Ampere. Okay. The force of the conductor depends on the direction and amount of current. It depends on the current. Okay. When we increase the current by increasing the number of battery, the force will also increases. It depends on the direction and also the amount of current. Then one more thing, the conductor and the direction and strength of the magnet. The force will also depends on the direction and strength of the magnet. So this force depends on I and B, these magnetic field. Okay, so force depends on I and B. Okay, then there is an important law, that is Fleming's left hand rule. In the previous classes we discussed about Fleming's right hand thumb rule. Okay, we studied right hand thumb rule, but it is left hand rule. It gives the direction of force. Okay, it gives the direction of force. Based on this rule, according to this rule, stretch the thumb, forefinger and index finger in your right hand such that they are mutually perpendicular in direction. So place your left hand in such a way that these fingers are in mutually perpendicular direction. Thumb, then forefinger, and middle finger. They place this as mutually perpendicular direction. Mutually perpendicular in direction. Then if the first finger points in the direction of magnetic field, this is magnetic field. This is the first finger, and it points towards the direction of magnetic field. And the second finger is the direction of current. This is the second finger. It will give the direction of current. Then the force will appear in this direction of the thumb. Okay. Then the second finger in the direction of current. Then the thumb will point in the direction of motion of the conductor or the force that acting on it. Okay, it is F, M, C. Just remind it as father, mother, child. Okay, father, mother, child. That means it is the force experienced by this coil, and it is a magnetic field. It is a magnetic field, and it is a current. Okay, so take a magnet, the U magnet, and place a coil in such a direction that it is inward to the board. Okay, it is inward to the board, and connect this wiring to the battery. Then this conductor will experience a force. This is north and this is south. You want to find these things. Okay. We want to find these directions. First, magnetic field. Align your forefinger in the direction of magnetic field. It is from north to south. Okay, north to south. This is your forefinger and align this in this direction, downward. Then what is the direction of current here? It is the positive terminal and the current will point here in this direction. So current inward to the board. This magnet is placed in this way, and the coil should align inward to the board. So current it is magnetic field. Then current should place in such a direction that it is inward to the ball. So in this way, this magnetic field, this current, then the thumb will points along the force that acting on this coil. So force should be in this direction. Force should be in this direction. Okay, this coil will move in this direction. Okay, this coil will move in this direction. That is the importance of Fleming's left hand rule. It gives the force that acting on a coil which is placed in the vicinity of a magnet. Okay, it is an important law. Is an important law, Fleming's left hand rule. Then next question is, write examples for device they work using the principle of current carrying conductor and magnet. The motor principle. What are the examples? Electric motor, generator, loudspeaker. Loudspeaker also work based on this principle. Okay, and microphone and measuring instruments. Some measuring instruments also use these applications. What is this application? Motor effect. When we place a magnetic field in the vicinity of a current carrying coil, then it produces a force. That force use these devices. Okay. Then next topic is electric motor. What is an electric motor? Electric motor converts electrical energy into mechanical work. That is mechanical energy. Okay. An electric motor is a rotating device that converts electrical energy into mechanical energy. Electrical energy is converted into mechanical energy by using this electric motor. Okay. Then it used in electric fans, refrigerators, then mixers, washing machines, computers, MP3 players, etc. These are the applications of motor principle, and these are the devices by using this motor principle. What are the major parts of an electric motor? It is the basic structure of an electric motor. These are magnets, north, south. These are magnets, and in between these two magnets, we should place a coil. This is called armature. This is called the armature. Then also you want to connect a battery and a split ring brush. Split ring brush. These are the parts. Two magnets. Armature is the rotating part, and a split ring used to split the current, and brushes connect these wires into the rotating part, that is armature. Then battery, it is the external power supply. Battery is the external power supply, and by using that power supply we make a mechanical energy, a rotational energy by using these arrangements. That is called the motor principle. Okay, this is the basic structure of electric motor. What are the parts? Remember that split ring, armature, magnets, brush, battery. These are the major part of a motor. Then explain the working of an electric motor. It's an important question from this chapter. You want to firstly you want to draw this figure. Draw two magnets and mark north and south. And this is armature. This rotating part is armature. Connect that armature by using a brush, and also slip ring, also split ring. Okay, split ring, use split ring and connects it with the battery. When we provide external power supply, that means battery, the current will flow through this armature in this direction. Current is flow from positive to negative, that is from here to here and then here after this negative. It is the complete circuit of electric motor, and based on the motor principle, this armature will experience a force because it is placed in the vicinity of magnet. Okay, it is placed in between these two magnets. That means this coil, this current carrying coil, placed in a magnetic field. it should experience a force. It is a rotational force. How it works? When a current passes through the coil, that is armature, when a current passes through the coil placed in the magnetic field, the arm AB moves downward. You want to study these sentences same as that of this. Okay, because it's an important question. The arm AB moves downward. We want to check that motion based on Fleming's left hand rule. Okay, the arm AB is here. Arm AB, then CD. Okay, based on Fleming's left hand rule. What is left hand rule? Stretch these three fingers and align the magnetic field in this direction. What is the direction of magnetic field? It is from north to south. So north to south. Place this forefinger in this direction. Then what is the direction of current? Direction of current. It is a three-dimensional figure. So the current is inward to the board. That is armature. This direction is three-dimensionally this coil. This armature is placed in between these two magnets. That is the direction of current is inward to the board. Okay, direction of current is, look at this figure in three-dimensional way. Then you get that this I is into the board. So direction of magnetic field is here and direction of current is into the board. Okay, this the direction of current is into the board. Then what is the direction of force? Direction of force will give the thumb points in the direction of force. That is, it is downward. The arm AB moves downward. The arm AB moves downward. That is, the arm AB moves downward. Then arm CD moves upward. Arm CD moves upward because apply Fleming's left hand rule. Direction of current is outward to the board. Direction of current is outward to the board. Direction of current is outward to the board. Magnetic field is from north to south, and force will get the direction. Force will experience in the direction of the thumb. This upward. So this CD moves upward. This arm downward and this arm upward. It will experience a rotational effect. That is why it acts as a motor. Okay, the arm CD moves upward. Then after a half rotation, the direction is reversed based on Fleming's left hand rule. Then it will continue. You want to explain these things in more. Okay, but it is a short. Okay, then we want to study more about that motor. Okay, what is a commutator? Commutator is a device which is used in this armature coil. Okay, what is commutator? It is a device which reverses the direction of flow of current through a circuit. A commutator helps to reverse the direction of current in a simple way. Here, it is a device used to reverse the direction of flow of current through a circuit. It is called a commutator. In an electric motor, we use split ring as a commutator. In electric motors, the split ring acts as a commutator. This is an electric motor. These are magnets, north and south. Then this armature. This is armature coil, and we place a split ring at this portion. This split ring helps to reverse the direction of flow of current.
Okay, look at the board. Our next question is, for commercial motors, one can use these three changes. For simple representation, we only used the coil, a single coil. Okay, so for a commercial motor, we can use an electromagnet in place of permanent magnet. Electromagnet is proper for commercial applications. The large number of turns of the coil. large number of turned coils are used in commercial motor, and a soft iron core on which the coil is wound. It helps to increase the efficiency. Okay, so soft iron core, and on that soft iron core the coils are wound. Then what is an armature? Armature is a part of an electric motor. Is a soft iron wounded by coils. Okay.
Then what is electromagnetic induction? Electromagnetic induction. It was discovered by our Michael Faraday. It was discovered by Michael Faraday in 1831. Electromagnetic induction means electromagnetic induction means a coil linked with a magnet produces a current. A coil linked with a magnet, it's a magnet, produces a current. This is galvanometer. That current detected by this galvanometer. Okay. In 1831, Michael Faraday made an important discovery, that generation of electric current from a moving magnet. A coil is linked with another magnet. When there is a change in this magnetic field lines, it produces current and induced EMF. It was discovered by Michael Faraday. Now, what is electromagnetic induction? What is the statement of electromagnetic induction? We have to explain that things. Whenever there is a change in the magnetic flux linked with a coil, linked with a closed circuit, an EMF or a current are induced in the circuit. Whenever there is a change in the magnetic flux linked with a closed circuit, an EMF and a current are induced in the circuit. This is called electromagnetic induction. This is coil linked with another magnet. Magnetic flux means field lines per unit area. That is, this is a magnet and these are magnetic field lines. When we move this coil into this magnet, it crosses these field lines. There is a change in the magnetic flux. It crosses that field lines. That means a change in the magnetic flux. Whenever there is a change in a magnetic flux linked with the circuit, an EMF or a current induced in that circuit, then it produces a current in this coil. So whenever there is a change in a magnetic field linked with a coil, it produces a current in this coil. Okay, you can do this experiment very easily. Okay, then what is galvanometer? What is a galvanometer? It's a device used to measure electric current, but there is a property, it can move, it can detect negative current and also positive current. Okay, a galvanometer is an instrument that can detect the presence of current. Detect the presence of current in a circuit, and it can deflect in either sides of the zero mark depending on the direction of current. It can also measure the direction of current. It can measure the negative current and also positive current. That is the important thing in a galvanometer. The needle in a galvanometer is always present at the center portion. The zero value is at the center. If the current is positive, then the needle will move to the left side and to the right side, and if the current is negative, then the needle will move to the negative side. Okay,